Okay, so in the previous lessons, you have learned how to find the probabilities, right? And we had some multi-stage experiments and modeling there too. So I assume that you know how to find the probabilities in a lot of different applications. So we're gonna do some applications here. These problems that I'm gonna show you is directly from the homework problems in MyMathLab. So hopefully this help you to complete your homework successfully and understand what's going on in the probability. Okay, the first problem is this. If the probability of a child being a boy is 1/2 and a family plans to have 7 children, what are the odds against having all boys? So we need to talk about odds against or odds in favor first, right? So odds in favor and odds against. So already you get to know these are opposite to each other, right? Odds in favor means something, the event that we are talking about so something that will happen in favor of that event to not happen. Okay, so will happen, I will just say yes to no ratio. So odds against means then no to yes ratio. So by solving the problems here, you will understand what I mean by that. Looking at this problem, it says the probability of a child being a boy is 1/2, and they want to have 7 children. So let's consider first child to be a boy. The probability for that first child to be a boy is 1/2. How about the second child? Does the first child, whatever the gender is, does it affect the second child's gender? No, it doesn't. It's still 1/2. Third child to have a boy, it's also 1/2, all the way to the 7th, right? It doesn't get affected by the previous, gender of the kids. So we know the first child to be a born boy is 1/2, second child to be a boy is also 1/2, and so on and so on and so on all the way. So that means the probability to get all 7 boys, 7 children being boys will be first child to be a boy, second child to be a boy, third to be a boy, fourth to be a boy, fifth to be a boy, sixth to be a boy, seventh to be a boy. So we know the probability for that. All 7 boys, all 7 kids to be boys in straight row should be this probability, which is 1/128. It's very, very rare. It's really hard to get 7 straight boys, right? So knowing that, we know odds against is this. Out of 120, let's go with the odds in favor first, because I think it's easier. Odds in favor, having all 7 boys in straight row should be like this. Out of 128, only one time you can have all 7 boys in a straight row. But the other 127, this is not gonna happen, right? So odds in favor should be 1 to 127. Then what's odds against? That means that will not happen. That will not happen to that will happen, right? Out of 128 times, only 1 time that will happen. So in favor, 1 time it will happen, but the rest of it, 127, will not happen. So odds against 7 straight boys is that will not happen to that will happen. So together, that makes the denominator. Does it make sense? So odds against having all boys should be 127 to 1. Okay, you can of course write this into words as that. Okay, that's what it means. You're gonna have more problems like this, and we're gonna have a little bit more practice on that. Number 2, if the probability of an even event happening is 76 over 87. So we know, let's say that event B, let that event be an A, then probability of event A is 76 over 87. Do you agree? Okay. Then what is the probability that will not happen? Because we already know how to solve it, right? 1 subtract probability of A. That is the probability of event A not happening. So we know that's gonna be 1 minus 76 over 87. 1 is of course 87 over 87. So 1 minus 76 over 87 is 87 over 87 minus 76 over 87. With the same denominator, we can just subtract it. 87 minus 76 is 1187. So we know this number is the number that will not happen out of 87 in total. And 76 will be that event will happen, right? So the question is asking odds against it happening. So we are talking about not will happen first, then that will happen next. That is odds against it happening. So does it make sense? Okay. Then what's odds in favor? We can just flip it around. It's 76 to 11. Okay. Hopefully by now you have an idea about odds against and odds in favor. Okay, let's take a look at number 3. If the ratio of men to women in a room is 21 to 17, so let me write that. Men to women is 21 to 17. What are the odds of a woman being chosen if a person in the room is chosen at random? So we are doing odds in favor of women. Odds in favor of women is, we are talking about women to men, right? Which is 17 over 21. That's the answer. Pretty straightforward, isn't it? Because this is odds against being a woman. You can just flip it around, right? Okay. If you don't understand, pause the video and watch that. Solve it by yourself and watch the video again by rewinding it. Okay. Let's look at number 4. Suppose the odds against winning the lottery are 45,000 to 1. So odds against the lottery is 45,000 to 1 means this is not gonna happen. You're not gonna win lottery for 45,000. Then you're gonna win only one time, right? So what is the total? To find the probability of the event of winning the lottery given these odds means you need to find the total number. Probability of winning is the total number, right? It's the denominator and only the winning here. So the total is when you add these two together, right? 45,001. And the winning is only 1 out of that. Because this is the number that will not happen. And this is that will happen. So together it's 45,001. And you're going to win only 1 time out of that. So winning probability should be 1 out of 45,001. Then what's probability of not winning? So let's say losing. That's 1 minus 1 over 45 45,001, which is 45,000 over 45,001, right? Okay. Now, let's look at number 5. Suppose you have 4 quarters, 11 dimes, 3 nickels, and 6 pennies in a box. So, in a box, you have 4 quarters. Let's just write that. 4 quarters, 11 dimes, 3 nickels, and 6 pennies. One coin is selected at random. What is the expected value? So expected value is how much do you expect, right? So what you need to do is each coin has value. For example, quarter has value of 25 cents. So you can do 0.25 if you want to consider that as a dollar. If you don't like that small, you can just do 25 cents. So let's do with 25 cents. So per quarter, you expect 25 cents. But what is the probability for that? Let's think about it. You have only 4 quarters out of how many total changes do you have? 4 plus 11 plus 3 plus 6. So 4, 11, 3, 6 all together. 4 and 6 is 10. This is 10. And 11 and 3 is 14, so together is 24. That's the total. So 4 out of 24 is the probability, right? So you multiply that and add dime. Each dime, the dime's value is 10 cents. And what's the probability to get a dime? 11 out of 24. And for nickel, each nickel you can expect 5 cents. What's the probability to get a nickel? 3, because there are 3 out of 24. And to get a penny, if you get a penny, you expect 1 cent. And what's the probability to get that? 6 out of 24, right? I would not simplify here because in fraction fraction addition, you need to have common denominator. It's already common denominator, so I will just multiply the numerators, okay, by keeping 24 as the common denominator. What's 25 times 4? It's 100. And you have 10 times 11, 110. 5 times 3, 15. 1 times 6, 6. So you have 210. And you have 21, so together that's 231, right? So 231. 231 divided by 24. Let me calculate that. 231 divided by 24 is 9.625. Cents, right? Because we did everything by cents. So you can say it's about 10 cents. Or you can just go exactly 9.625 cents. Okay? Alright, let's move on to number 6. How could you use a random digit generator or random number table to simulate rain if you know that 70% of the time with the conditions as you have today it will rain? One idea, look up for random digit generator if you don't understand what's going on there, okay? But you're gonna be given the table, so take a look at that carefully. So what you can do is since you're gonna use only the digits, you can assign the digits. So for example, from 1 to all the way to 7, you can say that if the random generator appears as 1 to all the way to 7, you can say that means it's rain, because that makes 70% of the time raining. And the rest of it, 8 to 8, 9, 10. So I will just write the 8, 9, 10. You can say that's not gonna rain, right? Then you have 30%. That's 30% not raining, and you have 70% raining. Together, it is 100%, right? So by assigning 1, 2, 3, 4, 5, 6, 7 to be rain, and you can assign 8, 9, 10 as not raining, then you can generate the random digits and record the result. Okay? And then it's very, very much simulating, the situation of this example. Okay. On a roulette wheel, half of the slots numbered 1 through 34 are red and half are black. 2 slots numbered 0 and 00 are green. So, if we draw it, you don't have to draw it, but to make it a little bit more sense, you can have 34 slots and you have 2 more, so total there are 36 slots. It's hard to draw, right? So each one has 9 of them, but let's suppose you have 32 there, and you can alternate the color, like black and red. So black and red, black and red, and then black and red, black and red, black and red. However, these 2 slots are in green. These 2 are in green with 0 and 00. Okay? Otherwise, you're gonna have black and red alternating, and there are 34 altogether. So you're gonna have how many blacks? Yes, 18 blacks, and you can have 6, is it 17? 17 black, because half of 34 is 17. 17 black, and you're gonna have 17 red, and you have 2 more with 0 and 0, right? So total you have 36. So you understand what's going on there. On a roulette, half of the slots numbered 1 through 34 are red. So half of that is 17. So 17 are red and 17 slots are black and 2 are in green. What are the odds against red slots? Odds against the red slot. So you need to find probability getting red. Then you can easily find it, right? Probability of getting red, there are 17 red slots. What is the total? 34 plus 2 more. So there are 36. Then it says odds against, not gonna happen, is what? You can do 1 minus 17 over 36, which is what? 36 over 36 is 1, minus 17 over 36 is, to the calculation, 19 over 36. So not gonna happen is 19, and it's gonna be red is 17, right? So odds against red is not gonna happen 2, it's gonna be red 17. 19 to 17. So by now you need to know what odds against or odds in favor mean. Okay. Number 8. A student wants to know why, if the odds in favor event are 3 to 7. If it's 3 to 7, that means will happen is 3, will not happen is 7. So to find the probability, of that event, you need to think about the total. What's the total? Total is 10. You need to add them together. And will happen is 3. Then will not happen. So complementary part of that should be 7/10, right? The probability of event occurring is not 3/7, but it has to be 3/10. Okay. Number 9. Two-person game, 4 coins are tossed. If exactly one head comes up, one player wins. If anything else comes up, the other player wins. Does each player have an equal chance of winning the game? Explain why or not. Why not? So let's go systematically to solve this problem. So in two-person game, only 2 players are playing. 4 coins are tossed. So we can think about all the possible outcomes, right? You can have all 4 head or only one. Let's go with 1 tail. So if you go with 1 tail, this can be a tail, but you can have the 3rd coin to be a tail. 2nd coin can be the tail, or the 1st coin can be the tail, right? So we are done with 1 tail. We can also have 2 tails. What if we have these two tails? And well, this can be the tail, or with this one, this can be the tail, right? So we are done with the last one to be tail. What if the 3rd one is to be tail? So we are done with the last one, and so these 2 can be the tail, or these 2 can be the tail. So we are done with this 3rd one and the 4th one to be the tail, or you can have 2nd one to be the tail, but since we are done with these letter parts, these 2 can be the tail. So we are done with the 2 tails. Let's consider now 1 head, so 3 tails. So you can have all 3 head and last one to be the, oh, hold on, we are done with this one, right? So we are doing 3 tails. What if all 3 are tails and the last one is head? Or the second from the last is the head and the rest of them is the tail. Or the second one is the head, head, and the rest of them is the tail. Or the first one is the only head and the rest is the tail. Or all 4 are the tails. So we counted all the possible outcomes, right? How many are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 outcomes. That's the subset. Outcomes, right? So the number of subset is 16. Now we are considering only about exactly 1 head comes up, 1 player wins. So let's say probability of 1 player, let's say A, to win is when there's only 1 head comes up. 1 head comes up. Out of 16, only 1 head comes up. Let's circle that. Only 1 head comes up are these 4 outcomes, right? So there are 4 out of 16. Then probability of exactly 1 head comes up is 1/4. Then the person A or 1 person wins. So winning, for a person A win, the probability for that is 1/4. Then rest of them, the other person wins, right? So we can say it is not a fair game. Okay, let's move on to the second one. Number 10. A basketball player shoots free throws and makes them with a probability 4/5. Makes them, probability is 4/5. What is the probability of the event the player will miss 4 in a row? So since 4/5 is making the throw, we know miss the throw for the one game, one shoot will be 1/5, right? Out of 5, 4 he will make, then 1 he will not make. So to find the probability, the event player will miss 4 in a row. First time he will miss is 1/5. Second he will miss is also 1/5. Third he will miss is 1/5, and fourth he will miss is also 1/5. So the probability to get all 4, he will miss all 4 in a row will be this. 1 times 1 times 1 is 1, and 5 to the 4th is 625. So the probability he will miss 4 in a row is 1 out of 625. Now I think this is the last problem. Which spinner has 2 colors, lime and violet, such that the probability of this event getting violet on 2 spins is 9/64. So getting violet on 2 spins has to be 9/64. What does that mean? That means, so probability of getting violet and getting violet again is 9/64, right? So to find just one time spin should be what? That means probability of getting violet only should be square root of that, right? Because you square this to find, both times probability, because these show you probability of violet and you squared it, you multiplied it twice. That is squared is 9/64. So probability of getting violet should be square root of 9, which is 3, square root of 64, which is 8. So you need to find what represents violet 3 out of 8, right? So let's see this one. 1, 2, 3, starting from here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 in total, and violet color you have only 1, 2, 3. So yes, it shows 3/8 there. So this should be the answer. How about this one? Violet is 1, 2, 3, 4 out of 5. It is not 3/8. How about here? To get violet, you have 1 out of 3. So no. And this one, violet is 1 out of 4. So no. Okay, so this is the spinner that represents 2 spins as 9/64. Okay, so we will stop here. This is section 3 of chapter 9, and you have one more section to go in this chapter. After that, you will have the test. So I will see you again next time with section 4. Please check your email, my message, and check my math lab to make sure you complete all of the homework assignments, including quiz and review too. Alright, have a great week, and I will see you guys next time.